So we have enterprise approach, deep dive, what client expects. I think last day we just understood not an outcome of a POC, and we understood what is a POC is, and they don't want learners, they want versatiles. So these are the few points that we need to initially understand. What client expect. Now, I think you know who is a client. I just got an example, banking example earlier, but let me take it again. So let's take a bank, because last time also we took the banking example. So let's continue the same. Bank is our client. Probably is a local client, probably is an international client. So depending on the Sage region or whatever, depending on the organization, they might support only locally, they might support internationally. Now, if you take Virtusa, we have a global footprint. So we have local clients, we have international clients. And whoever it is a client is the person who expects a service from us. Let's say it's a bank. Bank is the client. But the problem is they don't expect outcome of a POC. Outcome of a POC. So what do you mean by outcome of POC? I think last day we understood the POC. POC is proof of concept. It's a very basic way to gather knowledge. That's why. Why we do a POC? Because the team, the relevant team who is going to give the solution, currently not having the knowledge of what they are going to do. That's why they are doing a POC. If the team is a professional team, well-skilled team, well-capable team, there no need to be a POC. Right away, they can go for the what? Solution. Enterprise approach they can take. So most of the cases, I think last day we understood this one. Let me just quickly tell you. This is what. So last day we went through this one very quickly. We remember the POC outcome, component based, and we went scenario based, and finally only we went pilot projects. So normally, if the team is expert team, the solution team is expertise team, and they are going to be here, enterprise grade solutions, enterprise grade solutions. Otherwise, POC. So today what we are trying to understand, how to do an enterprise solution. That is where we stopped last day. We stopped it here. And let's try to understand what is the enterprise approach is. The client, they don't expect POCs, because the problem is, even to do a POC, you need the infrastructure. You can't, without having computers, without having processing power, networking, and storage, you can't do a POC. No, POC means, again, you need a database, and you need a middle layer, you need a front end. There's some kind of a time also required. So sometimes, if the solution team is not capable enough on the final solution, sometimes even for this POC, the client may have to sponsor. But even by client may have to sponsor, they may have to bear this cost as well. So there's a question mark whether they are going to do it or not. If not, the solution provider, if it is Virtusa, if it is whatever other WNS or whatever other organization, they have to bear this cost as well. Therefore, I mean, this is not acceptable in enterprise grade solutions. We have to right away go for the enterprise solution, because team has to have that particular knowledge. And they don't want learners. That's the other thing. In a client, in a project environment, that means if there's a project means already client has awarded us, they have selected us as the solution provider. That's why there's a project. Before the project, I'll explain it again. Before the project, the business case has to be approved, everything has to be approved. Then only the project will get initialized. Let's say the project is initialized, now there's a team, but client doesn't want learners from the team. They need what? Consultants. They need professionals. When there are more learners, what's going to happen? The value addition is low. They need value creators. Client expect value to be created for their environment. That means they want solutions. A learner is not a solution provider. He's trying to learn from it, and therefore the final outcome is not credible. Credible means there can be what? Bugs and a lot of issues. That's why. And they need versatility. This is another one. Versatile list. Versatile list means, I think on the right hand side it is there. Continuous upskill, cross-skill, and reskill. Versatile resource. Now you all have to be like this always. Let's say you currently the client is expecting a certain solution. Let's say again our example, mobile bank. In banking, they need to develop a mobile application. Now to develop this mobile application, you need the front end, you need the middle layer, you need the back end, you need the database, you need web technologies. If you are going to containerize, you need to know container technologies. So how many? For the front end, you might have to know Flutter, cross-platform development, Flutter, Dart, and there are other things, okay? And React.js, Angular, the front end technologies. Then the middle layer, what are the web technologies? We are going to deploy this one. Then the database, whether it's going to be SQL Server, whether it's going to be MongoDB, whether it's going to be data lakehouse, Delta lakehouse AI, whatever. Okay. Then likewise, there are a lot of technologies involved here. Now, currently, your team might be aware of these technologies. That's fine. But the problem is, in IT world, these are keep on changing. Technologies keep on changing. Now, you know, even currently, the trend generative AI trend. That's why there are new trends. Now, earlier, we were talking about warehouses. Then it became, that is long time back, more than 10 years, 20 years back, it was warehouse. Then it became what? Data lake. Then it became what? Lake house. Now we are talking about lake house AI. So that's why things are changing. So as the things are changing, the adaptability has to be there as a resource. That is who is known as a versatile resource. Versatilist. Versatilist is a person very flexible, willing to adapt anytime with any technology. So clients love to keep this nature of professionals in their environment because very flexible, very adaptable. Quickly, they have higher learning agility, cross-skilling, upskilling, reskilling for any technology. That's all. That is needed. And this is a theme maturity because now for the already the IT research publisher, they have already published these things. Published in a sense, they have clearly mentioned for the next upcoming 5 years, the survivors in the IT industry. Who are the survivors? Versatile resources. Resources who are willing to upskill, cross-skill with a higher learning agility. Quick learners. Those are the resources who are going to survive in IT industry for the next 5 years and going forward. Because things are changing very fast. With generative AI, it's going to change many things. We can talk about that one later. Almost the change has been started. And that is the first thing. Then organization's perspective. If an organization is having that much of resources who are capable of adapting quickly, more the resources they have in that nature, that means more versatile resource they have within the organization. As an organization, they are facing the competition in a better way than the organizations who are not having that kind of resources. That means they are taking the competitive edge. They are leading. So in both sides, it's going to benefit. That means for the employees, who are adapting quickly to the new text, they can survive. And the organizations also, they can survive. They can make many profits and they are winning the competition. So these are themes going forward. Already research publishers I mentioned. So, and then they expect guidance from a consultant. That's why. If you are a consultant in the particular project, let's say you join an organization and you are placed into this mobile application development project, and if you are holding the title of a consultant, associate consultant, lead consultant, senior consultant, you are a consultant. Consultant must act as a consultant in the client environment because client expecting consultancy from you, not testing work. That's very clear difference because professional input and a learner's input totally different. Okay? So they expect you to act as a consultant when a question is being raised. Right away, they want the answer. That means they want a fixed solution, not a workaround. There are differences. When a question is being, when a challenge is come, you can give a workaround. Workaround is what? That is all-rounders work. All-rounders means temporary fixing the problem, but going forward, again it might break. That's because it's workaround. It's a temporary fix. But as a professional, as a consultant, you have to give a fixed solution, not a temporary workaround. If it is a temporary workaround, that has to be highlighted and mentioned. Since we want to jump this step, temporary, we just fix this one like this. Then clearly it has to be mentioned with a justification. Other than that, if you always trying to do the all-rounders work, all-rounder means he knows everything, but he's not a what? He's not a professional because he knows everything little by little. When a critical problem comes, all-rounders work not going to work. Because when a critical problem comes, we need expertise, not all-rounders. Expertise are the people who have mastered, certified on certain technologies. So they know exactly the permanent fix. Whereas all-rounder, he knows everything here and there, that thing little, this thing little, that thing little. Therefore, he's not going to give the permanent answer when a critical problem comes. For a basic problem, he might give answer. So that's why we need consultancy from a consultant. So that is what client expect these things. So these all are the features I'm explaining in the enterprise level project. Enterprise level project. And you can see again the value creation I mentioned. Value creation. They expect value addition for the project. Of course, whenever you are working in an organization, you had always think what is the value you all are creating. Now, for example, you are on internship. You are on internship, you have to think, okay, what is the value as an intern I am generating to the organization? That you have to build that logical argument and see. The day that you start internship, you are a total learner. You have been paid certain amount, but you are a total learner. So am I adding a value or am I getting the value for me? You have to balance it. What's the contribution? What is given back to you? Give and take. So currently as an intern, normally you are grabbing more rather than adding value because you all are learners. But going forward, when the things are getting matured little by little, you are gaining experience, you are becoming certified on certain technologies, and your recognition going higher, then you become value adders, not value takers. That's what client expect resources who are adding value to their project. Because you are paid, you are billable, then they need enterprise approach. That's all. So let's try to understand what is this enterprise approach is. What is this enterprise approach is? Okay, so let me start it from here. Let me not take these big words at once. Like in enterprise approach, we need to look at this. What is the business architecture? I'm not sure you have anyone heard about business architecture and information system architecture. Okay, shall we ask few questions? Because I told you last time also, if I keep on talking like this, it will be a monologue. But I told you, I don't want a monologue, I need to have a dialogue. Even though it is online, let's have to have a dialogue. Anyone knows anything on business architecture? What's a business architecture? Can I have a few voices? Business architecture. Is the first time you all are hearing this? Okay, so I think the word is too big. You can ask from Bart chat. Don't Google. Ask from Bart chat. Even now you can ask from Bart chat what is a business architecture. But the problem is terms like this, you won't be able to understand at once. Anyway, let me just slowly tell you. Then we have information system architecture. And the third one is we have technology architecture. You might know this at once. All your languages, let's say when you want to develop a solution, now again our banking solution. Bank is looking for a mobile application. And they might tell the requirement is out of all core banking, mobile banking, corporate banking, they are looking for a priority solution as a mobile application. They want client to have a mobile application to increase the efficiency, to add more quality to their banking services for the client. In technology architecture, what you are looking at here, I'm taking the easiest one, right? Easiest one. Explaining technology architecture is the most easiest, I think, that you will understand at once. Technology. So to develop this particular mobile application, you need to have front-end technology. I told you this one earlier. Middle layer technology, back-end technology, back-end development language, data storage, everything. So this is all about technology. What is the operating system we are going to use? Is Linux-based, Windows-based? Is all cloud-based? Or it's going to be containerized or not? It's going to be Kubernetes or not? Front-end is going to be Flutter, Dart, or React.js or whatever other things. What is the front end and what is the middle layer? What is the back end developer? It's going to be .NET Core, or it's going to be Springboot, or it's going to be something else, Python, whatever, Golang. whatever the language you are going to use. So this all comes under technology architecture. But the problem is, in enterprise approach, this comes last. This comes last. Before that, these two are in high priority in the enterprise approach. But in an unmatured approach, this comes first. That's the thing you need to understand. Now, if you try to give this, so let's say now, okay, let's take a typical example. Let's say now bank is your client and you have been invited to visit the bank because they want the solution done. And now the appointment and everything is booked, and now the organization, let's say whatever, let's say XYZ organization, let's not take the names, specific name, XYZ organization, you all are working for that. You have, one is having a title called solution architect, other one is having a title called project manager, another one is having a title called business analyst, another one is having software engineer, developer. Now for this particular appointment, business analyst is going to go there, one or two developers is going to go there, solution architect is going to go there. So that is the initial meeting you are going to have. Now what is this? This is a client visit. Client visit, solution providing organization has got an invitation because client is looking for a software solution, and as the solution provider, now organization, XYZ organization, it is a software company, they are visiting bank, ABC Bank, whatever. Now the first meeting happens. Bank will say, look, we need this kind of a solution. What is the problem? We have a problem. Currently, all our customers physically visiting the bank, and sometimes there's a big queue on these counters. There's a big rush, even for transferring funds, even for basic credit debits, they are coming to the bank, and even for saving account opening and fixed deposit opening, they are coming for the bank. So we need to optimize this one. We are looking for a solution for this. We have heard there is something called mobile banking, and not mobile banking, mobile applications can be developed, and we want something that nature done. So they will explain in their terms. Banking terms, there can be some banking terms, there can be normal general English terms, because they are not IT organization. They have to be very careful. We are IT people, we know all the technical jargons, but bank is not IT organization. It's a non-IT organization. Because when you solutioning IT organization, non-IT organization, those are different approach. We have to be very careful. Bank might have IT department, that's a different thing. But because of that particular department is not capable of handling this much of complex solution, that's why they are calling you. If it can be done in-house, they don't call you. So therefore, we can't expect the in-house IT department also to be so matured to handle this particular challenge. You have to be very careful here. They have already now already told the requirement. Probably only those 5 to 10 lines they are telling. That's what they understand. Now here, as soon as to get this requirement, now this is a requirement. No? What is initially we are getting? Requirement. And we can say need as well. Need and requirements are totally two different things. You need to understand it clearly. Bank might have many needs, but out of the needs, we need to get what are the exact requirements they want. Definition is usable representation of a need is a requirement. Usable representation of a need is a requirement. So they will say we need iOS mobile, we need Android mobile solution, we need this feature, that feature, everything they will say. But there are many needs. Out of the needs, as the solution provider, we need to get the requirements. So that's why in your team, there's a role called business analyst. So now, very highly, it's time the business analyst has to take the lead, and out of business analyst has to take the lead out of all the needs, you need to get the requirements. Okay, once the initial meeting happens, now probably this is very first time, 1 hour or 2 hour meeting. Now they have told what they have to mention. Okay, you say, okay, we heard your requirement. let us do the homework. Now we are going back to the organization. Now once you come back to the organization, there can be two approaches. The first approach is, what do you do as unmatured developer, unmatured team? This is what you will do. What you are going to do? Okay, a client is telling a mobile application. Okay, we got this. They are looking for, they need some value addition to the bank. They need to reduce the queues. Okay, let's do this. Okay, we know the technology, how to develop a mobile application. We know the front end, we know the middle layer, we know the back end. Let's start coding, start developing. That is fine. This is an unmatured approach. This is what you take actually. As beginners, this is what you will do. Not only you, anyone who is not coming on the enterprise approach, this is the nature. But this is not what client expects. Because this unmatured approach, probably after 1 month or 2 months of time, in the mid of the solutioning, it might fail. Client might reject your delivery. Client might reject your delivery. So once the delivery is rejected, you are not given the payments, lot of issues are there. Code red projects. We don't need to go there. From the beginning, we need to take the enterprise approach. So how are we going to take the enterprise approach? That's the thing. So that is why here there are three things. Now, if it is not enterprise, you are starting from here, technology architecture. Right away, you defining the technology, starting solutioning, developing the code. That's not going to work. You have to start from here, business architecture. So under the business architecture, the very first thing is, what is that? We are going to have something called business case document. Business case document. So whose job is this? Business analyst job. Because currently you are not awarded this project. ABC Bank has not selected XYZ organization as the solution provider. It's still under negotiation, it's still the initial discussions. So it's up to the XYZ organization to understand and digest the client requirement, come up with the business case document, indicating all the functional requirement, non-functional requirement, solution requirement, and again the tech stack and everything. They had mentioned, and the budgeting and all, and the delivery timeline and everything, and the project delivery style, agile or DevOps or whatever this time method, indicating everything. They had to provide this particular business case document. So business analyst, with the support of project manager, solution architect, or developers, because business analyst might need support on certain technical terms. So with the support of that, he or she need to prepare the business case document. Once the business case document is done, if it is approved, and you have to tell in the business case document, out of all of these requirements, we are going to give priority for these requirements, because now bank has mentioned many needs. Out of the needs, we have identified these requirements, and out of this requirement, these are the prioritized requirements, and these are the red dot requirements. We are going to deliver in this order. These red dot requirements first, others are my product backlog, and in sprint 1, we are going to go agile delivery style. Sprint cycles will be delivered every 2 weeks. They will be deliverable. We are going to deliver a feature for you. We are going to give a release for you, and it's going to go live. It will be in production. And in the first release, these are the features. Second release, these are the features. Third release, these are the features. So likewise, in the delivery timeline, with a clarity, you have to mention this is the way the project is going to flow. So these things must be there in the business case document. Once these things are given to the client will look at it, he do analysis. If they like, they will give the green light. Okay, we are awarding this as a project for the XYZ organization. Let's go ahead. That is how. This is the enterprise approach I am telling. Let's continue this one. Okay, then they will say this can be done in fixed budget. Fixed budget means for the entire project 40 million. That's it. Or time and material. Time and material means plus 2 weeks plus feature plus delivery. This is the cost. Second delivery, this is the cost. Based on time, it can change as well. There's a higher boundary. It can't go beyond this budget, but normally that is time and material. No fixed cost sheet. At once they say, this is the cost for this. If you like, you can go ahead. So once the both parties agreed, we can go for the sign off, client sign off, solution provider sign off, then we are okay. Then only a project will be initialized. A project will be initialized. That is what. So now only we are having a project. Getting it? What do you mean by we are having a project? Now project manager will form the teams. Who are the teams? You're going to have the business analyst, you're going to have the development team, you're going to have the QA team, you're going to have UI UX team, you're going to have a project manager, solution architect, operations team, likewise. So now we are having a project. So that is how enterprise approach should continue in that way. And after that, I think in the slide, it is there, business case. So because now these things are like this, project charters or project chart and everything, solution requirement specification, software requirement specification, everything will come once the business case approved. These are process maps and everything, user journey. So these are the techniques that BA is using to get the business case done. And even after that also, process maps and everything has to come because they need to understand the current business process. Before delivering, before start developing, the project team has to understand how the work is done at the moment. Everything manually or some existing automation is there. So understanding the existing business process is very important. User stories likewise and business use cases. Yeah, so this to understand how they work, UI, UX and everything. So these all comes under what? Business architecture. So these all are part of business architecture. Business architecture. Because to form the business architecture, you need to understand all of those things. Because business architecture doesn't mean only the processes. Only the processes. Because in an organization, there can be, the organization may be process driven or may not be process driven. We understand processes in an organization represent the core value chain. What do you mean by core value chain? The main value within the organization is whether they are following process or not. Process is what? Set of workflows. Workflows are what? Set of user journeys. Very easy. Now, what is a user journey? Okay, let me give high level. User journey means, okay, now let's say for example, now you will have visited bank. No, let's say you are going to the bank. Now, what is the objective of going to the bank? Open a saving account. Okay. Now, how you are going to go? Go to the bank, open the door, go to the counter where savings accounts are opening. So this is user journey. What is user journey? Walking into the bank. Why you are walking into the bank? Because you are going to open a savings account. Step 1 of the user journey is open the door, go to the savings account counter. User journey part 1. Then what is the part 2? Okay, now the counter, you have sit in the counter. Whoever the officer will ask, okay, what can I do? And you say, I want to open a savings account. Then the fellow will open their side system. The system is there, it will open the system, and like the process goes. So that's the second part of the user journey. Now you can see 2 user journeys are there. Because from the banking side also there's a user journey that officer is using. From the customer perspective also there's a user journey. But at the end of the day, both have to integrate together to complete a workflow. What is a workflow? Your part and the bank part. So integrate both together, it becomes a workflow. So generally, if these workflows are defined very well, that means what? When you open the door in the bank, it's clearly mentioned, there's a board telling, if you need a savings account, you have to go here. There's a process to follow. Interconnecting several workflows will create a process. So the smallest part in the process is a user journey. Collection of user journeys will make a workflow. Collection of workflows will make a process. Now the problem is, now I'm taking banks. Normally in organizations, not every process is well optimized. There are loopholes, there are gaps. That's why if the processes are well optimized, it's very easy to identify the business architecture. Business architecture. Because to form the business architecture, every user journey, every workflow must be captured. That's what. Now, if an organization is representing a crystal clear process for everything, then what? Definitely that organization, the value chain is very high. The value creation for the client also very high, value creation for the customer also very high, and as an organization, they are taking the very high big competitive advantage because everything is well standard, SOPs, standing operation procedures are there for everything. Then it's not driven by people, it's driven by processes. If something goes wrong, the responsibility is not on the head of the person, but in the process. The process is questioned, not the person. That's the way it should be. If something goes wrong, the process should be questioned. If the particular responsibility holder has followed the process accurately, that means he has done his job. He has been asked, okay, if a client is open to fixed deposit, this is the way to do. So he is following the SOP, standing operation procedure, part of the business architecture. He is following that. If he has followed that perfectly, that means he has done his job. But having followed that also something goes wrong means that means process is not well optimized or well rectified, or it's not, there are some loopholes. So in such organization, it's fine because process is questioned, then you can get back and find out the loophole and fix it and get the standing operation procedure done and document it, and you can do it. But in those places, less issues because people are there to follow the processes. Okay, so I'm just trying to explain little by little bit on business architecture side. Whenever you are trying to solution a requirement, look at this, check whether current client, this particular bank, whether they are following processes or not. If they are not following processes, you are in trouble. Why? As a solution provider, you are in trouble because you are trying to automate manual work. When you try to automate manual work, you can't be opening books and pages and modifying manually. It is all system driven. To drive a system, you might have step by step. Well, process should be indicated step by step. So if the process is not there, you have to clearly tell them, okay, there's no process, we have defined the process. So there's a gap in the business architecture. So we need to find out whether you have business architecture document. If not, we have to draw it. That is the enterprise approach thing. Otherwise, if you create this mess, if you don't sort out this mess initially, that particular issue will come into your side as a solution provider. Because finally the client will say, hey, look, we have paid this much and we have spent this much of time with you, but look, the solution is not as per the requirement. So they will blame you. So don't fall into that trouble. That's why if you are a consultant, you know the way forward, how exactly this particular project should be driven, and you are driving the client in the correct path. But you need to have that experience. That's what enterprise approach. Getting it? Okay, let's not spend that much of time here. We can go on explaining, but let's go to the next one. Then comes information system architecture. So still we didn't touch upon any technologies. Still now there's a project. Now the teams are ready to start. But then what's going to happen? Now you need to look at the information system architecture. What is the information system architecture? Okay, now we are just touching upon what is the software architecture, what are the architectural patterns, what are design. Okay, now a little bit of development is going to work. A little bit of work is given for the dev teams now. Having all of these things defined, now a little bit technical terms is going to discuss with the development team. Why? Now the requirements are clear. We have the red hot requirements, sprint. Project manager is telling, okay, we are going to run agile. We are going to have 2 weeks sprint. First 2 weeks. These are prioritized requirements. You have to deliver this requirement end of the 14th day because 2 weeks. Release has to go out for the QA team in the first week. Then because sprint end means second week sprint end means what? A feature has to be delivered to the client. So mid of the week, first release has to be given to the QA team for testing. Likewise. So now there's a delivery timeline, delivery plan. So as per the delivery plan, development team has to start developing. Okay. But before that, what you have to do? Solution architect has to come up with the solution architecture diagram. Solution architecture diagram. Okay. Actually, before commencing sprint 1, this diagram has to be ready. Solution architecture diagram. I think I show you last day few solution architecture diagram, very high level I show you. I think we remember this diagram last day I just mentioned. This one, solution architecture diagram. Okay, let's have a look at several other solution architecture diagrams as well, because this clearly tells where this project is going to be. It clearly mentions these are the technologies this project is going to be delivered upon. There's going to be container, there's going to be event-driven architecture, whether it's going to use Kafka, whether it's going to be a cloud solution, on-premise solution, whatever. Whether it's going to use AI, generative AI, whatever. So very important to have the solution architecture diagram. So before sprint 1, a high-level solution architecture diagram, before developers start developing, high-level solution architecture diagram should be available. So the responsibility goes now from BA to project manager, now to whom? Solution architect. Solution architect. So look at the flow of the responsibilities. Initially, it was totally on BA. Then it came to project manager. Now it's heading for solution architect. Solution architect. So once the solution architect define the diagram, then it is being handed over the dev team for these three. For these three. Now it is totally relevant for our discussion and totally becoming relevant for our module as well. So we are on microservices. Now only we are coming there. So what is software architecture? This is software architectural style. So this is what we are learning in this particular module, microservices as a software architectural style. Software architectural style. Getting it? Software architecture, we are telling whether we are going to go object-oriented, whether we are going to go service-oriented architecture, whether monolith architecture, but no, we are telling we are going to go with microservices. Not only microservices, we are going to go with microservices, event-driven containerized architecture. That is what we are going to do. So that's the first high-level starting point for developer, but that also is not allowing him to start developing, because software architecture is not, that is a 360 view. It's an architecture. Architecture will not allow you to start development. You can't start checking code for the code repository by looking at the architecture. You have to understand architecture pattern and design patterns. We will talk about this thing in detail. Now for the microservices, architecture pattern also known as microservices. I am not giving the definitions here. I have a separate document for that. I will show you that one in a while. Architectural pattern also microservices. Design patterns. What are design patterns? So once you define the design patterns only, you can start developing your software. I tell you example. For a mobile application, probably initially we are looking at the login page. Login, front-end login. User has to do a username and password, forget password, reset password, whatever. So login is the very first feature we are going to deliver for the client. So to start coding login, the design pattern is what? With microservices, API gateway design pattern, integrated gateway design pattern. So that's why for every development in microservices, there's a relevant design pattern. So your development has to follow a design pattern. If you are developing something, some code without following a design pattern, that is not an enterprise approach. That is not an enterprise approach. It's just very basic, primitive, layman level of coding. In a code review, it might get failed. The code quality is not there. Even if you try to get the code quality with SonarQube or something, it will fail that time. It will not pass the code quality. So therefore, you must follow design pattern. Let's try to understand the design pattern. This is I'm theoretically explaining the enterprise approach. So let's try to understand those things. We'll go to certain design patterns with examples, with codes. I'll share the document. I have the documents. Design patterns. I think I hope you are getting it. Now only the developers have an idea. They are going to start developing. Business case is done. Project is initialized. Sprint is initialized. Solution architecture diagram is available. Now design patterns are available. Okay, let's start coding. Start coding. How? technology architecture has to be defined. To start coding, technology architecture has to be defined, the last one. Now only we are talking about a technology. What is the operating system? Where is going to be what is the coding, cloud native coding, low code coding, no code coding, and what is the development platform, and a lot of things, data engineering, and yeah, middle layer, back end. Here everything is not mentioned actually. This is only few things are mentioned in the technology architecture. What is the front end? What is the middle layer? What is the development platform? What is the back end? Everything. Technology has to be, because these tech is stack already there in the solution architecture diagram. In the solution architecture diagram, I'll show you another good example of a solution architecture diagram. It is known as technical clustering. The front end, what are the technologies? That is a front end cluster in the solution architecture. The middle layer, what is the cluster? Back end database, what is the cluster? Technical components. Core, if it is going to be event-driven Kafka with Kubernetes, that should be the core. If there are analytics, what is the AI part? What is the analytics part? Likewise. Let me show you example. I think it is easy for you to understand. I show you example. Okay, this is another one. Okay. Now in this solution architecture diagram, this is a requirement is what now? We talk about the banking requirement. No. This requirement is what? Real-time data visualization dashboard. That's the requirement. Enterprise-grade solution with event-driven architecture. So this is what you are going to do as well. In our project, I told you we are going to discuss that on today's self. We are going to develop a project in this particular course, particular module. Our module, our project is going to be event-driven, containerized microservices. That is what we are going to do. So we need to understand how the solution architecture diagram is going to be in that particular solution. We might not be able to do 100%, but we have to take the challenge and go there because that is where the industry demand. The more you get closer to that particular demand, it will be more easy for you to adapt to and get into a particular job role and play the role as a professional rather than a total beginner. Okay, and so this is an example of a solution architecture diagram. Now you can see this is really complex. This is an industry production level solution architecture diagram. What is trying to say? See, the grouping is done here. Databricks, this is for analytics. This is the storage. Storage technical group is here, Databricks. And this is the core part. Core part is this particular solution is going to get containerized and it's going to be on cloud. That's what AWS, Amazon, Elastic Kubernetes cluster is the AKS. And it's going to be, you can see containerd not on Docker. Latest runtime is containerd. CRI is container runtime interface. And Istio is to make sure internal container, within the microservices, you need to communicate in between microservices. No, we'll talk that little by little. Because it's not like monolith architecture, modularized development. In a modular development, these are tightly coupled. No? For example, in a modular development, if you get the service-oriented architecture, monolith architecture, the whole login module is a login module. There are no microservices. No. So authentication, authorization, everything is one module. Login module, no, is one place. So there is nothing called communication between functionality because it's one bundle, tightly coupled. But if you do the same login with microservices, you're going to have separate microservices. Authentication, one microservice. Authorization, one microservice. And within that also you are going to break down. Enter username and password, one microservice. Change password, another microservice. Verify, another microservice. Authorization, that is authorization, authentication. No. Authorization means once the user is logged into the system, which role the fellow is going to be paid. It's going to be admin or it's going to be normal end user, likewise. Altogether, login functionality can be broken down into 5 microservices. 5 microservices as per the API gateway design pattern. So now the problem will come. When it's going to be microservices, these are independent services. Not like the modularized architecture. These are not linked together. Username entering knows about username entering and password. That's it. Microservice. Verification knows about once the username and password are taken, go to the database and check whether a particular user exists and whether he has right to access the database. That's it in that microservice. Then authorization means once the fellow is logged in, this fellow is admin or a normal user, that's all. So that microservice does only that. So you can see each microservice, atomic, unique, independent functionality. Then there's a problem how these microservices are talking to each other, communicating. This is where we are talking about a discovery server, very basic discovery server, like Eureka. So Eureka is a very basic level discovery server. It's not suitable for enterprise level. We can think about RabbitMQ and all, that's fine. But in this solution, we are going to take Kafka as our discovery server, event-driven pattern. So when you take that, it's an advanced event streaming platform, then what's going to happen is going to establish the communication between these microservices based on events. What are the events? I'm going to tell you very basic example because I don't want to make this discussion very complex initially. You need to understand little by little. But in here, the event is one. In our mobile application, login. The fellow go to the mobile interface and click login. Click means put the hand, touch login button. Then the screen comes in, enter username and password. So that's the first microservice. No? Touching login button is an event. It's an event. So that's why event driven means that based on the events, we are driving our programs. So touching login will call login microservice. So each event has to be streamed. How is it streamed? Kafka. Kafka has to know this is the first event, and when the end user click that, I should run this particular microservice. He has to know. Then once that microservice is success, then this particular user need to authorization. Once the authentication is done, I must run this microservice. So this communication, the governance part, Kafka has to know. So in there we have a publisher and subscriber model. We will learn that one later. What I want to tell you is it's not like the monolith and the service-oriented architecture. These independent services need to communicate to each other. But in a containerized environment, it's going to be a little different because each microservice is going to represent by a container. We'll understand that one later. So in a containerized environment, to establish the communication between the containers, we need another particular discovery service called Istio. We will come to that one later. Kafka can do it, but Kafka is doing a different job here. He is handling the event. Istio is managing the containers, communication between containers. Let's try to understand it later. Okay, so now this part representing the core components in our solution architecture diagram. Core components. Okay. Then I'm taking it to further. Now this is our development work, and this is our code repository, and these are the feature branch and master branch. That's the way to represent. And this is all about connecting to this your code check-in and everything has to happen here. The containerization has to happen. Finally, this is going to be to manage the Kubernetes cluster, kubectl and node. And you are going to have ultimately, again, this is accessing this is visualization dashboard. You can access the front end using browser, as well as you can access the front end using Power BI, and here we have generative AI. So in this particular solution architecture diagram, we can see 7 cluster groups. First thing is, if you look at from here, this is the visualization dashboard, analytics, front end, plus second one is generative AI. Third one is storage, going to be Databricks. You can take it as Lakehouse AI, that is fine. Databricks. And this is the core components for core part of our solution architecture diagram, Kubernetes with these two and management side. And this is the development area, and this is code repository. So likewise, different technical components are there. So this is the web interface, because reports can be, analytical data insights can be approached, can be accessed using browser plus Power BI. Okay, any questions, team? Again, I'm not sure I'm keep on explaining, but any questions? Are you getting it? Or totally Greek? You can tell me. And you have few voices. Dilip, can you hear me? Dilip, Priyanta? You can, if you can't talk, you can put it in a chat, no problem. Clear, right? Okay, fine. Thanks. And yeah, we have Dinesh. Dinesh, are you okay? Are you clear? Dinesh.
Yes, sir.
Okay, fine, fine. So if there are any questions, you have to answer because this is the standard that we should go. This module will go in this standard because as I mentioned, I'm not going to focus that much of theory. We are going to look into the solutioning. That's why I'm showing these things as well. But yeah, still we didn't touch upon any coding, but definitely we are going to start it. Hope this is clear. Fine. So let's now get into a little bit of still a few more theories are there because we can't be totally forgetting the theories and getting. Okay, let me explain that one first. I think that will help you to understand the rest. Okay, now this human software architectural style. Let me open that one. I'll upload this to the LMS. I got the LMS access. Access means the module created yesterday only. So I had upload the previous recording as well. Uploading in a sense, I think I told you all the recordings are going to be given from this. I think last day I showed you, right? It's going to be on this YouTube, my learning platform YouTube channel. It's going to be shared via this. Fine. I gave you the link last day as well, and you can keep it subscribed because all the latest tech trends are happening here. I think 2024 tech trends, it will be published probably very soon, and you can have a look at it. And generative AI and everything is latest tech trends are there. It will be published through this. You are going to have a separate playlist. Still, it not there, but it will be on. There will be a playlist telling university sessions. So from that only, you'll be accessing your recordings. Yeah. So let me show you that document. Software architectural style. So this is what I mentioned. Yeah. Any chat? What about the nodes? Yeah, everything will be uploaded to the LMS. So this is only the recordings will be there on the channel. Others all will be uploaded. No worries. So for example, what I'm showing you now, this particular whole document, this is for your notes. So no need to write. You can write down anything while explanations are happening. So I'm not going to dictate the note for you to write down. All the notes, necessary notes will be uploaded. Now this is one of it. This is the very first starting point actually, and software architectural style versus architectural patterns versus design patterns. And going forward, I'll be using other slides as well for you to give. There are certain basics also. No? While we do the development, there are certain basics also need to be covered because at the moment, whatever said and done, this is graduation, right? This is the bachelor's level. So we can't be expecting forgetting all the academic part and go to the practical and industry. No, that is not going to work. So certain basic theories also needed. So therefore, I'll be giving you those things like comparing the monolith architecture, microservices architecture, and service-oriented architecture. There are the important aspects as well. How do you properly size the microservice, scope in the microservices? Now, for example, this is one of the biggest problems even the seniors are facing. So when you try to do microservices, okay, out of the requirement, which part we are going to include for this microservice? What is the boundary? What is the limitation? Why can't we put this feature and that feature together and create one microservice? Questions are there like that, no? That is scope in the microservice, defining the boundary. So let's try to understand how that those things also can be done. Yeah, so this is it okay? That chat message, is it clear? I think that is what you're looking for, right? 968, right? Somebody, okay. Right, I hope it's clear. Okay, thanks. Yeah. So this is software architecture style. I think in the PowerPoint, if you look at this one, this is what software architecture, architectural pattern, design pattern. Now for this, the theoretical document, what I am showing now. Architectural patterns, design patterns. The theory is given. What is a software architecture? I think no need to be this much of big. An architectural style is a conceptual way of how the system will be created. Very high level theory. What are the architectural styles? There you go. From the history, client server, component based, layered, hexagonal, message bus. So I think even now the message bus is there. Even you can see this RabbitMQ is kind of service-oriented architecture, message bus. Those goes together. Let's not go there because it's too old now. Right? And N tier, 3 tier, those also has been there in the industry. You know, those things are getting change and migrate into other architectures. Object-oriented, of course, those are there. You can see presentation, assertion. Now, in the industry, mainly what you see is this object-oriented, SOA, and of course, this is the latest. Of course, actually, even though we are telling latest, we have the multi-tenancy application development as well, even though this document doesn't say that. Multi-tenant application. We have, no? Yeah, we have. Multi-tenancy is there. Okay. Cell architecture didn't pick up, but that is not, doesn't matter, no need to. But so we are here, we are discussing this, the latest one. Microservices, containerization, multi-tenant. We are not going to touch upon multi-tenancy that much because it's going to be a little bit complex. So we need to understand these things first. And we are going to add upon event-driven architecture for this. Let's try to do those. And service-oriented architectures, object-oriented architecture, I think the monolith is not given here, but monolith architecture also there. But anyway, the comparative analysis will be done. Not the oldest one. We don't need to go here. But for you to understand only, I have put it these things, this much of architectural styles were there in the industry. But now we are working on SOA, microservices, object-oriented, and monolith. So I'm not going to deep dive these things now, but this document I'll upload, you can go through it. And when you go down, let's deep dive this in little by little as I may need it. And you can see what is architectural pattern is explained here. And few architectural patterns are given, event-driven, you can see microservices, and design pattern, what is the design pattern also given. Let's try to understand these things later little by little. You can, if you go down further, now what is this document is doing, you can see it is deep dive, principal microservice architectural patterns. This one. Principles used to design microservices architecture, architectural patterns. So these patterns taking most popular industry architectural patterns one by one and giving examples. If you go down, it is there. See, very first one, microservices design patterns for effective collaboration. Because I told you, every coding has to be backed by a design pattern. Without a design pattern, you never develop a microservice. If you do so, that is not a good code smell. Right? It's a weak code. It's not a standard code. So therefore, we don't do that. And see, these are the popular patterns. There are more than this, but at least I have given few here. Aggregator microservice design pattern. So what is aggregator design pattern? And how it works, explain. I think example also given with the coding. See, this particular, let me check whether this is accessible. Yeah, it's working. No. Yeah, now this GitHub repository will explain with coding examples, with code, how the aggregator design pattern is implemented. The jar file, if you look at the jar. Anyway, let's not go there now. So that is how this document is being developed. For each design pattern, there's example given with a code repository. And again, change microservice design pattern and how it works. And for that also, I think for that one, a coding example is not given, but doesn't matter. But most of the things, API gateway design pattern, which I just mentioned, and again, coding is given. So have a look at it. Before I am going to explain, just have a proactive understanding. Just high level, take a look at it. Then it will be easy to understand when I am going to explain as well. So see, a lot of examples are given. I'll upload this document. And this is finally enterprise approach. I think I explained these things. That is fine. Okay, so that is one of the notes, initial notes I'm going to provide you. But not only that, we have certain other basic definitions. These things I am going to, what microservice? L1, technologies for microservice, okay. What are microservices? Basics. Okay, see. What are microservices? Still, we didn't explain these things, but I'll be uploading these documents. So enough of notes you are going to get. Yeah. And that one, I think we have more documents here. Lesson 1 flow, what is that? Yeah, this is industrial analysis of microservices. Yes, that's okay. I'll go through those things separately. Springboot. Yeah, this is, yes, we are going to springboot, no? So how to get started with springboot? So all the needed documents are there. Still certain documents I haven't finalized as well, but I'll upload these things. Okay, right. Yeah, this is about APIs. So not everything is needed because a lot of other sessions are happening in other universities as well. So that's why I have this much of notes, but not everything is needed for you because we are no need to give you the semester. I mean, first year students' work is not necessary for you. Are fourth year. So I'll be filtering and I'll be uploading necessary things for you. I don't think it will be taught what is an API, right? I think everybody is aware REST API and all, but let's touch upon those things. Web API, REST API, there are differences. Okay, fine. Let me tell you what is the project we are going to start with. That's the next thing. Because probably on next day, we can start designing our solution architecture diagram for the project. We have to have a solution architecture diagram. Otherwise, it's not going to work. And this is very high level. This is for expert. This is fine. This is the enterprise way of presenting a solution architecture. But for you, I don't think now. I don't think any one of you will be able to explain this one by looking at this, because this is all about very summarized and concise. So architect should be explaining this one. Over 1 hour, this can be explained. Fine. So what you are going to do as a project? What is our project? Let me open a Word document. Our project is going to be like this development work. In terms of technologies, we are going to use, okay, I don't think front-end development. Anyone who knows Flutter, no Flutter, React.js, Angular here, React Angular, anyone who knows that can remember. In chat or wherever we can respond, we have React expertise here. Or Angular. What are your front-end technologies I'm asking? No. Anyway, if you are there, yeah, if you know that, we can touch upon that and answer some front-end interface for our particular project. Otherwise, you can ignore that. That doesn't matter. So anyway, the core technologies are going to be in our project Kubernetes. I'll start because this way we're going to have Kubernetes. And in this case, how we're going to use Kubernetes. I don't think you all have access for cloud. So therefore, pre-tier accounts will have issues when you're trying to do a full deployment. We can do, not an issue, but I don't, again, creating pre-tier accounts for everybody, there can be challenges. If you have cloud access, I don't mind you are going for GK, I mean, Google or Oracle or AWS or whatever, sure, doesn't matter, right? That's fine, it's up to you. But for everybody to make it a success, we are going to use on Windows, not even in Linux. The problem is some are not aware of Linux. We are going to use Windows Docker desktop, right? Docker desktop Kubernetes. So let's install in our Windows Docker desktop and enable Kubernetes single node cluster. Single node cluster. This is what we are going to do. Because I'm not going to use Minikube. No Minikube. We can use Minikube. And there are other ways to represent. This is we are simulating Kubernetes cluster. This is the most closest way to simulate a production equal Kubernetes cluster. Because if you go kind, Minikube or other things, certain things are deviating from actual Kubernetes cluster. Containerization, doing a deployment, replica creation. So Minikube slight changes are there. So therefore, we are not using this. We are going to use directly this one. Kubernetes is a Windows flavor of Docker desktop and enable single node Kubernetes cluster. That's the first thing. Second thing, we need Kafka. Kafka installed. Zookeeper and the broker. Zookeeper and the broker must be up and running. This is our event streaming platform. Event streaming platform, because we are going to do, yeah, let's forget about this thing. Event stream now is correct, right? Event stream backup, because we are going to do event-driven programming. You may wonder then why not to use AWS Lambda and all for event-driven? No, Lambda is not the only way to do event-driven programming, no. No, Lambda is, I think, the industry due to the cost factor, people are deviating from Lambda. So we are not going to do that. We are going to do event-driven programming. So, and we are going to have that event streaming, and Kafka is going to play multiple roles. It's going to be event streaming platform, plus our discovery server will be that to communicate between microservices. And then our development framework is going to be springboot. Springboot backend development. This is what? This is the backend. That's why I asked front end is possible. If possible, you can come up with the front end as well. Otherwise, it's going to be only a web interface, right? The APIs. And Springboot as the backend. What else? Okay, analytics. We're going to have some dashboards. Data insight, visualization dashboard. And for this, let's try to use Lakehouse AI with Databricks. So I'm just giving you a full solution. Whatever possible, let's do. Our example, working with analytics with Databricks and all, this is a little bit out of our scope, because this is going to go data frames and JSON work, data transformations and also there. But getting to know generative AI with Lakehouse AI is a plus for you. So if we can touch upon, let's do, right? Depending on the time we have. But these are must. You have to do these things, right? And okay, then AI, generative AI, Databricks. In terms of technicality, these components will be enough for us, right? This we can build a solution. So what are you going to do now? This is just like the technical components, no? What you are trying to do? Let's we need to get a requirement again, and we need to get a business case. This is the business case, and this is what you are going to develop. And ultimately, let's try to have a basic dashboard. So I will give you what is going to be the business case, not today. I can upload in the LMS, what is the business case and not. And in that, you are going to have several requirements. There will be a client and particular business domain. There will be a client, and you had a requirement, and certain features should be developed, and likewise, which will be covering the design patterns, several design patterns with microservices. Okay. And it's up to you to select either IntelliJ or Eclipse or whatever, not our studio, Visual Studio. We have the VS Code, no. Use all the free tier tools, open source free tools, no, nothing paid. Otherwise, you're going to have license issues and all, no. Our database is going to be Lakehouse AI. Don't talk about these MongoDB and those things are going to get not going to work, no. And so we have free tier. Certain free tools are available in Databricks. So let's try to understand what is Databricks and all, and let's try to do some work there. But it's like this now. When you work in the Spring, we have the default S2 database. So we might use S2 database initially, because you need to at least understand the JPAs and how to connect, no, for the database. Once the basic, if you know those things, fine, we can skip and right away go to external database. That's fine. But if you are totally new for those things, we can take a look at those codings as well, and try to see how it works, right, without right away going for the Lakehouse AI. Fine. Okay, so this is roughly what we are trying to do in our project in technical tech stack wise, and details I'll tell you because sometimes on the fly I might change the processes and the workflow. So therefore, little by little, let's start developing. And if you can be ready on next day with at least with your which one IntelliJ or your development environment, IntelliJ or VS Code or whatever IDE interface, that's fine. We can try out developing basic microservices. Little by little, let's do this Docker setup and all, Docker desktop. Anyone has done Docker desktop? This is very basic. It's not so complex. The only thing in Docker desktop, you need to enable Kubernetes. That is also not a big challenge. Because if I ask you to spin up a Kubernetes cluster on AWS, that can be kind of a challenge, not the service. AKS, EKS, Azure, Kubernetes, they are managed services there, but we can't learn using as a managed service now because control is on their hand. What I'm asking is manually spinning up a Kubernetes cluster on AWS or Azure. So if I ask you to do that, that will be a challenge. I understand. Anyone has set up Docker desktop with Kubernetes here? Anyone has some experience? Do you have anyone in this forum? No. Is that? But I think we had some container experience resources as per our previous discussion. We got one. Install Docker but no Kubernetes. Okay, fine. That means you know basic on that. Okay. Anyway, I'll demonstrate that installation. Initially, we can develop some basic microservices and we can link it up with Kubernetes. That's fine. Okay, any questions on this? You know, you are getting a glimpse of what you're trying to do. Any questions? Okay. Right. For today, I'll do only this document, very basic one. Let me just open that and did I close that? But I'm not sure that this one is going to be too basic for you, but since the document is there, this one. Let me just quickly go to, because certain things might be important as a fundamentals. What are microservices? You know now. Microservices architectural style is an approach that develop a single application as set of small services. Each service runs in its own process. The services communicate with the client and often each other using lightweight protocols over messaging or HTTP. That's fine. I think you know these things. So in summary, I explained this one, I think, earlier, right? The microservices are not tightly coupled. I explained it login. I think this is much clearer. I gave example login, how is monolith developed, how microservice developed. No, it's fine. If you go down further, this is example shopping system without microservices. Now this is monolith. Monolith means the modularization approach, which is one of the old approaches, but it's still in industry. It is there. Now the biggest challenge is migrating monolith architecture to microservice. That is also there in industry happening. So shopping without microservice, you can see this is without microservice, web, mobile, server, shopping application, store, compute. So see, multiple functionalities are plugged in or clubbed into a one particular module called shopping application. So in there, store happening, card modification, configuration, adding, and everything is happening. So the web interface from the browser, this application will be accessed. This is only one module supporting multiple functionality, multiple features of the application. So you can see now then shopping with microservice. So if you decouple this architecture, if you break down this architecture to microservice, now you can see the same interface is there. So browser based or mobile based is accessing, but you can see store is a separate microservice, catalog that is for the configuration, then card, checkout. This is shopping application now. So this is a separate microservices. So you can see that. You can see special design pattern is in place, API gateway. So that means whatever the traffic has to be routed to the relevant microservice, not like this. There's no routing requirement because once it come in, because there's only one application. So based on the front-end usage, it will be executed. One application, but here it's not that way. There are independent services are running. Routing has to be happen. So therefore, that's why API gateway is there. And if the request is for store, it will be routed here, and the catalog will be routed here. And you can see at the bottom, separate database also there. Because but this is not a mandatory thing. I mean, we can't be having unique database for each and every microservice. But what meant here is for when it comes to microservice, the relevant data which requires to run that particular service, that is only requirement. For that microservice, there's a certain set of data needed. Now for the store, there can be, this is, let's say, product store, this is, what is this? Shopping, no? Shopping, and it comes under e-commerce, So under e-commerce domain, stores are there because now let's say if it is supermarket, if it is online shopping, in the supermarket we have stores. We have the sweet and we have the milk products in one store. Likewise, stores are there. No? So this is, we are talking about the stores within the supermarket, right? Not the warehouse stores. So in that store, when a client comes to, let's say, client is filtering and the fellow is going to order a packet of milk, let's say Lux Spray or whatever, Nestamort or whatever. Now then only that data is required for the database, for the microservice. Getting it? Because he no need to go for chocolates and the sugar and the vegetable and everything. Those data is not necessary to process that milk request, no, right? Only the relevant data process should be given for the microservice. That is the expectation actually. Otherwise, for example, let's say, now that is why it's indicated a separate database. Separate database means only the relevant data for the current process happening in the microservice. Microservice is responsible for always one process. That is the best design. So if this microservice is responsible for handling milk products only, yes, that's the best. Then only the relevant data for the milk products should be accessible for this as and when needed. So that's what mean by a separate database. Otherwise, it's not okay. You are going to have set of tables for milk products, and that database is a different database. That is milk database, and this is another sweet database, and that's not what it means here. We have to understand this one in more detail. Here, only theory here. What is the theory? Microservice at any given time should have access to only the relevant data. API call for the database should fetch only the relevant data. That's the most efficient way to process the microservice, or to request this client requirement to satisfy, to service this client requirement. That's the efficient way. Otherwise, if you have a single database like this what's going to happen. Every microservice is going to go API calls for this and search. It's going to take a lot of time to process this. No point having microservices. Right. Now, normally in latest, we have to make this one much efficient. We have the concept like data multi-tenant databases. So in a multi-tenant database, you can give only the necessary components, only the necessary data to the relevant microservice. Multi-tenancy architecture is possible. And again, we have data, not marts. There's another approach, data sharding, SHARDs, data shards. So data shards will give you only the necessary data for the microservice. Likewise. Anyway, hope you get it. The decomposition of tightly coupled module to microservice. And again, I think why microservice is used. So just keep on reading. I don't need to explain one by one. How does monolith architecture looks like? This is monolith architecture. The layman terms is only tightly coupled. I think you can see listed below is the challenges in monolith architecture. Yeah, challenges in monolith means now everything is one module, no? Inflexible, unreadable. If one changes happens, it affects everywhere because it's one module, no? So you can't do independent changes, and even if the testing has to happen, again the whole module has to be tested, regression testing, everything, because one change affects everywhere. And now you can see store development, inflexible monolith application cannot be unreliable, unscalable. Yeah, scalability is a big problem. because how come you scale the whole module with many functionalities? We are microservices, independent module, and very easily scalable. Block continuous development too. Slow development, not fit to complex applications. Fine. And why? What is microservice? Already we explained. Yeah, this is decoupling. You can see the business domain microservice 1, 2, 3. Based on the features, we'll understand how to scope the microservice later. And based on the features, we can have separate microservice in the development. Okay. Yeah. And again, here you can see differences between traditional architecture and microservices. Yeah, I think already understood in the previous example. And so this is what monolith approach. You can see this is microservice approach. It's the same thing. Routing component is there, API gated UI, and customer, product, and cart. What is trying to say? Single instance. Yeah, the whole module. This is taken as a module, no, whole functionality in one module and one database. But here we have multiple microservices and decoupled architecture. So this is tightly coupled, that is one module, each are integrated together. That's what it says, tightly coupled. This is decoupled and working independently, separately. That's what it says. And in fact, this discovery server component is missing here, should be drawn here. Otherwise, how these microservices are communicating each other is a problem, but that's okay. Yeah. And again, microservice architecture, this is another example. So you have the front end omni-channel, multiple channels are there to access and manage capabilities. Okay, this is the configurations. Microservice A, B, and REST API calls, message bus. So that's their discovery service there. Yes, that's fine. So it's, anyway, these are just basic explanation. Just go through the note. I'll upload this into LMS. And I think I'll give you more theoretical explanations in upcoming lessons as needed. The comparative analysis and note. Okay, so that is that one. After that, Spring MVC or Spring Boot, let's not take them today. Fine. Yeah, this is a very, I think, code. What is that? Let's say, very basic microservice. Yeah, I think you all know this, right? This is a very Spring, very basic code to say hello world. That's fine. So, because these annotations, I think you all know these things, basics. String hello, so we can request mapping. ABC, fine. That's okay. Right. Okay. So let's stop it for today here, and from next day onwards, let's start our development work and the solution architecture diagram. Let's try to draw it up and the installation also. So next day there will be multiple works we have to do, and I'll do the demonstration for Kubernetes installation as well. So little by little, let's try to develop and be ready with the IDE interface next day, right? So we'll have to have either Eclipse or IDE IntelliJ or VS Code, whatever, right? And I think all of you are having access to a computer. That is what I understand. But anyway, I have talked to Prabhanivanam as well, because I think practical sessions are separated on. I'll talk to that, right? So I think in last batch also we had separate practicals. I'll talk to her and see how it's going to be done. Anyway, I'll be demonstrating here online. If needed, only physical 1 or 2, but you can't. You want both, it's difficult. All demonstration I can do online. Yeah. Okay. Okay. Any questions, Tim, for today? Are you okay? Okay. No? Okay. Then let's stop here. Okay, then. Thanks, then. Okay. Good night.